From last week's episode, if you remember, we had a high-pass filter that we had biased. So we had a nice signal that was revolving around the bias point, VCC over 2. So this is what we had last week. Right, here's our high-pass filter right here in this upper section. And then our bias voltage here is down here. So let's just run that real quick so we can refresh our memory on it. And so you can see here that just as we expected, we have a bias point that's right in the center here, running at 1.65 volts. And you can see the signal coming out of the high-pass filter oscillates right around that 1.65 volts, just like we wanted. And it's somewhat clean, so we got that going for us. So this was what we were left with last week. Now what we want to do is, last time, as we said, and still this time, right, is our signal is very small. Like our signal right here, you can see I just go from 5 to 4.9 volts right here. So just a 100 millivolt swing at about 8 kilohertz. And so what I want to do, though, is I want to bring this still into a micro, but with the way that it is right now, I would have to do a lot of math in order to calculate the peak to peak to see what the full voltage swing on this is. I'd have to get an average over the top. So if I do this, right, I'd have to do some sort of averaging up here to get about 1.7 volts, right? And then I'd also have to take a second one and get an average down here, which would be somewhere around, like we'll just say 1.6 volts, right? So I'd have to get those two averages through an ADC converter, and I would have to then do math and calculate to get the peak to peak. So I don't want to do that. I want to reduce my work on the microcontroller, and I just want to read one voltage. I just want to be able to read the peak voltage and know that it is what it is. And of course, we could say, well, I know that my center point is 1.65 volts, so I can just double it. Right, I can just read the maximum value minus the 1.65 volts of the bias and call it a day. But we don't want to do that, right? We want to be able to see this entire swing and be able to monitor and do a reading on this actual signal, not have to deal with math on our bias point. And the reason why is because if there's some discrepancies in this bias point, we won't see it on the output, right? So the other thing that we want to do is, because it is a small signal and our ADC on the microcontroller may not be that accurate, right? And so what we want to do is we want to actually put some gain on this so we can kind of see a little bit more of the voltage range on this thing. So we want to put a gain amplifier on the output of this and multiply it by, let's say, 2, right? We can choose anything, but for right now, we're just going to, for this example, we will say we want to put a gain of 2 on it on the output. Now what we want to do is we want to go ahead and put an amplifier on this circuit here. So we want to amplify this high pass output. So what we want to do is we want to put a gain amplifier on this high pass output. When we got two choices that we can choose from, either a non-inverting gain amplifier or a inverting gain amplifier. Both these amplifiers right here, the setup is set up for a multiplier of 2. The non-inverting gain amplifier, the gain is 1 plus the gain, which is R2 over R1, and in the inverting gain amplifier, it is just R2 over R1. So that is why we can see here we have 20 and 10, and we have 10 and 10, but they're both at gain of 2. And we can see that when we run this, our high pass output does what we want it to there. And if I select the non-inverting output, you can kind of see it. It does come down a little bit, but you can clearly see that it's saturating up here. And if I do the inverting gain amplifier, it just rails at 0. It's just because we're saturating this op amp, and there's nothing we can do about that. So what we want to do is be able to not do that, right? We want to be able to see the full signal that's coming out of the high pass output without saturating the op amp. So what do we want to do? Well, based on the fact that we have a 100 millivolt pulse coming into the input, and it's giving us the 100 millivolt output on the high pass filter centered around 1.65 volts, right? If we have a gain of 2, we want to be able to see that 200 millivolt swing on the output somewhere that we can feed into our microcontroller. But what we want to do is, because we know we've already seen that we can't have it biased at the 1.65 volts, otherwise we'll saturate our gain amplifier, right? What we want to do is we then want to shift that entire signal. We want to shift that entire signal down so that instead of reading the 100 millivolts going around 1.65 volts, we can actually see 200 millivolts going from 0 volts to 200 millivolts on the output of the circuit. And then we can feed that into our processor, and then the processor can just read the high on that, and we will see the peak-to-peak voltage just by taking a reading and averaging out the high output, the maximum of that signal coming into our microprocessor. So what do we have available to do this with? We have 3 op amps, we have 2 4148 diodes, and we have whatever resistors and caps that you want to use. What we want is an output signal that'll show 0 to 200 millivolts because of our gain of 2, and we must determine if we need an inverting or a non-inverting amplifier in order to achieve that goal. If you'd like to give this a go, pause the video now. Otherwise, stay tuned and I will go over the solution. So what we're going to do here is we're going to use an inverting gain amplifier in order to do this. And what we need to know is, what is this bias voltage that we need for the inverting gain amplifier in order to make this thing operate. So in order to get that, we actually have to, it's not as cut and dry as just like picking a voltage. Like we can't use the same bias voltage as over here. But when we look at this, we can see our gain is R2 over R1. The R2 over R1 is this R22 over R21 here. And when we start looking at the stuff, the formulas, which you can see right here, our bias voltage, because what we want to do is on the output voltage here, you can see it in this one right here, in this formula right here, right? When our voltage, what we want is, since it's an inverting amplifier, whenever we reach our peak voltage of the output of this high pass filter, that's when we want to register a 0 on the output of the amplifier, right? Because then it'll be sufficiently biased so that we're getting the whole signal going through this inverting amplifier. So what we want is this formula right here, the V out, it's minus gain times the peak voltage coming out of this high pass filter, and plus 1 plus the gain times whatever this bias voltage is, right? And that's what we're trying to determine here. So when you do the math, you can see we go 1 plus gain times the V bias equals gain plus the peak. And finally, we got V bias. We finally got V bias is equal to the peak voltage times the gain over 1 plus the gain, right? And so we wanted a gain of 2. So it's 2 over 1 plus 2, which is 2/3. And so our peak bias voltage has to be 2/3 the voltage of the peak voltage coming out of our high pass filter. Then what was the peak voltage out of our high pass filter? When we go here, we can actually see, we can just rough estimate it right now. So our peak voltage is going to be somewhere around like 1.7 volts. Right? So if we take our calculator, 1.7 times 2/3 equals about 1.322 volts. So if I go back here, 1.1332, and then if I run that, you can see there's our high pass filter coming out. And if we look at the output of our thing, we got exactly what we want, right? We can see here, if I hit the right buttons, we can see here, it goes from 0 volts And we can see the whole signal because we don't really bottom out. We can actually see it climbing up. So we got good bottom range. And we can see that the upper range, if we look at that, it's roughly about 200 milliamps or 200 millivolts on average. So now all we got to do is, because we don't have this as we don't have a voltage reference of 1.1332 volts anywhere in here. We can do another thing where we try to get a voltage divider and do that. But the problem is right now we are set with just a 100 millivolt range, right? But that's not the case, right? What we want to do is, like, let's say if I take this and instead I want a 200 millivolt peak to peak. Well, if I run that right now, because I've got this fixed, I've got this bias voltage fixed to that voltage, the output of our out thing now becomes saturated. Like, we're not seeing that full swing anymore. And even though I've got a 200 millivolt input, I should see a 400 millivolt output. But you can see here that if I go and just average this thing out, you can kind of see I'm only getting 300 millivolts. So I'm losing some bottom end. So again, if I wanted to make this operate correctly, I would have to then again go and say, well, what was my output? My output, if I measure that, is roughly, we'll just say 1.75 for the sake of this. So go there, 1.75 times 0.666 gives us a voltage of 1.1655. So if I change this to 1.1655 and then I rerun it, and there we go. Our high pass out still doing what it does. But now if I do, look at that, and there we go. So now we've got our inverting amplifier giving us the output that we want, which is about 400 millivolts on average, and we're able to see the 0 millivolt down at the bottom range. We're not saturating, right? We can still see the bottom end of the swing. So now the question is what do I have to do in order to make this bias point dynamic? Right, that's the trick. Now I got to make this dynamic based on my input voltages, right? So how do I can make this dynamic? So how are we going to bias it? Well, in order to bias it, we just need to be able to get that peak voltage that comes out of the high pass filter. How do we do that? Well, we use a peak voltage detector right here. This is our active peak voltage detector. That'll use the 2 op amps and the 2 4148 diodes. And so with that peak voltage detector, that output is then going to go into a voltage divider to give us our 2/3 for our 2-gain amplification. And so now our bias voltage is going to be 2/3 the voltage of our peak voltage coming out of our high pass filter. And then we can feed our high pass filter into our 2-gain amplifier. And then what will that do? It will offset it so that no matter what our input voltage is, we should always see the 2 times gain amplification from 0 to whatever that voltage is. So let's go back to our original one, which was 100 millivolts swing, and let's run that. And you can see here, this is we do our output. So there's our going across our bias voltage there at 1.65 volts. We can see that if we look at our output, our peak voltage detector, our peak voltage detector is basically running right around the peak voltage that we want. And then if we look at our output voltage, well, if we look at our bias voltage, you can see our bias voltage is hovering right around the bias voltage that we want for the peak voltage coming out. And if we look at our output voltage of our filter, you can see that we get our nice signal and we get about 200 millivolts on the output. And you can see that it does not saturate on our 0 point. So the question then is, will this work for multiple inputs? Well, let's go down and let's take a look. We're going to go down to a 200 millivolt swing on it. And what's the output look like? And so if we look at that, we get the average it is right around 400 millivolts. So you can see here it's about 410 millivolts for a 200 millivolt input swing. So you can see that we're able to take whatever our input pulse is through the high pass filter, bias it on that high pass filter so we can see the entire peak to peak voltage, and then using the peak voltage detector and the non-inverting gain amplifier, we can actually get the voltage output that we want, and we can go all the way up now to saturation of these particular op amps, because all of them are running off of 3.3 volts, so we just can't saturate any of these op amps and we will be fine. But like I said, it was a small input signal, so a 2-gain amplifier should be fine for a pretty wide swing. So then the question is, well, what do we got to do if we want to adjust this? Let's say we wanted to do a gain of 3. Let's say on this 200 millivolt swing, we wanted, instead of 400 millivolts, we wanted a gain of 4, right? We wanted to see 800 millivolts for this 200 millivolt swing, so that's a gain of 4. Well, remember the calculations that we went through, right? Our bias is based on the peak, so we'll still have the same peak coming out, right? But now our multiplier is going to change, right? So if we take a look at those multipliers, right, then we can see that if we want to gain a 4, right, then our multiplier is now 0.8. And so if I want 0.8, right, then I'm going to have to say, we can look at this right here, right, R4 and R3, right, so R3, R4, because I'm OCD about the units, and we'll just say that we'll keep R4 the same, 66.6, and then what do we want? We want to see actually, remember this formula, R4 over R3 plus R4, so just so I don't have to do some crazy math, we'll just let the thing do it, that plus that, right, and so that's 1 because that's 0, but let's say if we make that, so if we make that 33.3, which was the last one, you can see that this was 0.666 or 0.667, but I need that to be equal to 0.8, right? So let's see if I go down. Yeah, so let me go down some more. 15K, a little too much. So we'll go 17. Yeah, close enough, right? So 17K will give us right about 0.8. So if I go over here and I turn this into a 17K right there, and then that allows, this is a 2, remember 20 and 10. So now this is going to become 40K. So I can get my multiplier of 4. So I can get a gain of 4. And now if I run it, trying to move that little guy. So you can see if we average that one out, you can see right there, we're about 790 millivolts, right? Right about 800 millivolts. So that's how we do it. That's how we're able to take a signal, DC offset it, allow the gain amplification, and be able to detect the entire signal on the output without having to do some really crazy stuff. Well, depends on what you consider crazy, but this is what it is. High pass filter out into a peak voltage detector, and then those two signals feed into a non-inverting gain amplifier with some DC bias. So that's all I have for you this time. Thanks for watching. I hope you enjoyed the video. And thanks for all who have subscribed and shared. And if you liked the video, please again, subscribe, share, click the bell icon. And I will see you next time. Have a good night.